So which system of equations am I doing here? I'm looking for where the green line and the red line intersect. So again, the red line had equation y equals -1/2 x plus 10, and the green line had y equals 1/3 x plus 5/3. So now I need to solve this system to find this last corner point. And so to do that, we just do the same thing we did. I'm gonna plug this one into here. So I'll get -1/2 x plus 10 equals 1/3 x plus 5/3. And now I just need to solve this for x. And again, I have a denominator of 2 and the denominator of 3 appearing. So I'll multiply the whole thing by 6 just to get rid of both of them at the same time. So multiply both sides by 6. I think we're going to get -3x plus 60 equals 2x plus, and this was 10. 6 times 5/3 is 10. So I should get this. So -3x plus 60 equals 2x plus 10. And so now I just need to solve this for x. I'm going to add 3x to both sides, get 5x, and subtract 10 from both sides to get 50 on the other side. 60 minus 10 is 50. So I have 50 equals 5x. Divide both sides by 5. It looks like x equals 10. So the x coordinate over here is 10. And then I just plug this x equals 10 into either of these equations, and I'll do it with this one because there's a denominator of 2, which 2 goes into 10, so this will be nice. Y equals -1/2 times 10 plus 10. -1/2 of 10 is -5 plus 10 is just 5. So it looks like y coordinate is 5. So my 3 corner points are -20, -5, 5, 15/2, and 10, 5. Okay. Cool. So we found our 3 corner points. Now that we've done that and we found our 3 corner points, the final step is to find the minimum of the values that I get by plugging the corner points into the function. So we're going to go through and just plug them all into the function and see what we get. So at this point, the only information I need now are what the function is and what the corner points are. So I can actually, I don't need the graph anymore. So I'm going to erase it. And all we need are the corner points and the function. Everything else is gone. Okay. So all I'm going to do now are just systematically plug each of these into the function and just see what values I get. So here's what I like to do. I like to make a little table where we say, here are the coordinates of the corner point, and here's P when I plug in those coordinates. So I have -20, -5. I have 5 and 15/2. And I have 10 and 5. Those are my corner points. So on the left part of the table, I just collect my corner points. So I can erase these. And then on the right side of the table, I'm going to write the corresponding values for when I plug these into the function. So for -20, -5, remember P is -x plus 4y. So I'd plug in -20 for x. And I would put in -5 for y. For this first guy, just plug this into P. That's going to give me 20 minus 20, which is 0. So -20 is +20. 4 times -5 is -20. So I'm going to get 0. So when I plug in this corner point, I get 0. Next, I'll take the next corner point and plug it in and see what I get. I put in 5 for x. Oops. So I just put in 5 for x. It's -5. And then 4 times 15/2. That's -5 plus 4 times 15/2. Well, 4 divided by 2 is 2, which then times 15 is 30. So I'm going to get 30. So -5 plus 30, and that is 25. So when I plug in this corner point, I get 25. And finally, I'll plug in the last corner point. 10 for x, so I get negative 10. And then 5 for y, so I get 4 times 5. That's negative 10 plus 20, which is 10. So for this corner point, I get 10. Okay. So these are the values of the function at the corner points, 0, 25, and 10. We're looking for the minimum, and I told you guys that the minimum would have to happen at a corner point. So these are the values at the corner points. So one of these is the minimum. Which one is it? Well, minimum means smallest. So we just pick the smallest answer. So this, 0, is our minimum. 0 is our minimum. That's an arrow. So 0 is the minimum. So the minimum happens at negative 20, negative 5, and the minimum value is 0. Okay. And so we're done. This was the problem. So maybe this feels quite involved. There are a lot of steps. This is why we sort of broke it down into 3 sections for these ideas. But it all comes together, and this is what we get. So I'll pause here if there are any questions. I have no idea what time it is. Hopefully I haven't. Okay, so like 9 minutes left. Good. So any questions? Okay. I don't know. So maybe what I want to do next, so I've done one of these examples. What I should do with 9 minutes left is I know what I'll do. I'll do another example, and I promise this one will be shorter. Might as well do another example. This one will be a little shorter, and then maybe tomorrow I'll talk a little more and tell you guys about unbounded sets and what to do with those. And then we'll venture into solving the word problems and all that. Okay. So let me do one more example. It'll be a little less tedious, I think. We're going to find the maximum this time. Let's find the maximum of P equals x minus 3y, let's say. And we're going to subject it to the following constraints. This will be more in the flavor of a lot of these later programming problems. We'll have x, y greater than or equal to 0, y greater than or equal to 0. And I don't know, we'll set it up this way. Y less than or equal to negative 3/4 x plus, I don't know, how about 15? Yeah. So we'll set it up like this. Here's our system of inequalities. Here's our function. Let's see what we get from this. So I'm going to graph the constraints first, because I already have them. And I'm sort of going to fast forward here. If I have these 2 constraints present, then I'm automatically in this first quadrant, above the x-axis and to the right of the y-axis automatically. So I can kind of ignore the rest. So I'm just really going to focus up here. Yeah. If you ever have these 2 constraints, x greater than or equal to 0 and y greater than or equal to 0, you're automatically up here. You don't have to worry about the other quadrants of your graph. So that's a little shortcut. So I'm not even going to bother with these. I know I'm up here. That's where my feasible set will be. And so I just need to graph this last one. And so I'm going to do that. So I get y equals negative 3/4 x plus 15. I mean, it's already solved out for y for me. That's nice. So I just need to graph it. So my y-intercept is 15. How about I count by 5s? Just to make my life easier, so I don't have to draw 15 tick marks. So I'll count by 5s. My y-intercept is 15. And I'll count by 5s this way also. And the slope is negative 3/4. So when I go to the right by 4, I go down by 3. So I go to the right by 4, and I go down by 3. So it looks like this. And then I draw my line. Okay, cool. So there's my line. And where do I shade? Well, we could test a point, test 0, 0. That's not on the line. That would give me 0 is less than or equal to 15. That's true. So I shade underneath the line. So my shading is all in here, in this triangle that line makes with the x and y axes. So this is my feasible set. It's this triangle. And how many corner points do I have? Well, there's 1, 2, 3. Okay. Again, there's 3 inequalities, so it's not a surprise that there are 3 corner points. What are the corner points? Well, in this case, I happen to pick a really nice example where it's actually really easy to tell what all the corner points are. For example, there's 0, 0. This is 0, 15, because that's the y-intercept of this line, and it intersects the y-axis, which is another one of my lines I had to graph, 0, 15. And this last one, it looks like it's 20, 0. You might ask if I really drew that carefully enough to know that for sure. We could quickly solve to find out if that's true. What 2 lines intersect there? Well, that's the line, this horizontal line is y equals 0. And this other line is this y equals -3/4 x plus 15. Well, plug in y equals 0 here to solve this system. You'll get 0 equals -3/4 x plus 15. Solve that for x, and you should get 20. -3/4 of 20 is 15, and so you will get 0 here. So I promise if you solve this system out, you will get 20, 0. So I'll leave it at that for what the corner points are. So just to demonstrate this, really I wanted to demonstrate this process of finding the max once we know the corner points. So let's do that now that we have the corner points. Make our little table. So my corner points are 0, 15, 0, 0, and 20, 0. And now I just plug those all into my function. So my function says x minus 3y. So let's just plug these into x minus 3y. So plug in 0, 15. I'll get 0 minus 3 times 15. That's -45. So this first one is -45. Next, we'll plug in 0, 0. That's 0 minus 3 times 0. That's just 0. And then I'll plug in 20, 0. That's 20 minus 3 times 0. Well, that's just 20. So these are the values of my function at the corner point. We saw that the feasible set was bounded. It made a triangle, so it was bounded. So I know that the maximum happens at the corner point, and so all I need to do to find the max is just pick out the biggest result that I got, and in this case, that's 20. 20 is the biggest thing I got, so this is the maximum. And we're done. Okay. So I think we're about out of time. And so, yeah, there's like 2 minutes left. So I'll leave it at that for today. So guys, notice I published the activity 7.3 this morning. So start taking a look at that. With the stuff that I've given you now, you should basically be able to do the first half of it, I think. So it'd be good to get started on that. Tomorrow I can introduce the unbounded feasible sets so that then after that you could basically finish off that activity. I think I'll cover all the material for it. So if you have any questions, you guys can stick around today and ask them. Otherwise, take a look at the activity, take a look at the web work that I posted, and be on the lookout. In the next couple of days, I'll post some stuff about the exam so you guys are aware. But otherwise, if you don't have any questions, I will see you guys tomorrow.